Hello all, welcome to KT Semicon self-based learning module. Now, in this particular session, we will try to discuss about number representations in digital design. Before that, let me share my screen. So in digital, we can represent numbers in various ways. So the very first common method which we are going to use for representing a number is sign magnitude form of representation. And second one is one's complement form of representation and followed by two's complement form of representation. So we have one's complement form of representation, sign magnitude form of representation, and two's complement form of representation. Now let us try to understand them in detail. What do you mean by this? So the very first one is sign magnitude form of representation. So in the case of sign magnitude form of representation, we allocate one bit for representing your sign. For positive numbers, we are going to allocate MSB bit as 0, and for negative numbers, we allocate 1 for representing our negative numbers. For example, if we want to represent a negative number minus 3, then for representing this minus symbol, we use MSB bit as 1 and followed by the magnitude of this number is nothing but 0, 1, 1. So this is how we are going to represent a negative number, that is minus 3, in sign magnitude form of representation. Now let's say if I want to represent minus 5 in sign magnitude form of representation. Now how I am going to represent it? If I want to represent minus 5, then for minus symbol, representing my minus symbol, I'm going to use 1, and followed by for the magnitude, I'm going to use the magnitude that is nothing but 101. So this is how I'm going to represent my negative numbers. Let's say if I want to represent plus 5, then how I am going to represent? So for representing my plus, I use the sign which is known as 0, and for the magnitude which is nothing but 101. So this is how I'm going to represent a positive number. So in the case of your sign magnitude form of representation, you use your MSB bit for representing the sign of a number. Whether if it is a positive number, you are going to use 0, and if it is a negative number, we are going to use 1. Now, so for representing my positive numbers, the MSB I'm going to use 0, and for representing my negative numbers, I use my MSB as 1. So this is nothing but my sign magnitude form of representation. Now, the one of the small disadvantage of using this sign magnitude form of representation is, let's see one example. Let's say if I want to represent plus 0, then how I'm going to represent plus 0 is nothing but 0 followed by 0 0. This is nothing but my sign, and this is nothing but my magnitude. Okay. And let's say if I want to represent minus 0, then how I am going to represent? So for minus symbol, I am going to use 1, and for 0, I am going to use 000. So I can see for 0, for plus 0, I have one representation, and for minus 0, I have one representation. So for plus 0, for 0, I have basically two representations, but you don't have plus 0 and minus 0. But using the sign magnitude form of representation, we are able to have two representations for the 0. So this is the small disadvantage we are having in our sign magnitude form of representation. And one other disadvantage is we need some extra bit for representing our sign bit. Okay. Now, we can see here the range of numbers which we can represent using sign magnitude form of representation. The positive numbers which we can represent is 0 to 2 power n minus 1 minus 1. And for negative numbers, we can represent from minus 0 to minus 2 power n minus 1 minus 1. That means, let's say, if we have n is equal to 2, that means we have 2 bits for representing a number. Okay. Then using these 2 bits, what is the range of numbers which we can represent? Let us try to understand. So for plus 0, we are going to have, we are going to represent it as 0 followed by 0. So the plus symbol we are going to use must be a 0 and followed by the magnitude. Let's say if I want to represent plus 1, then what is that I'm going to use? 0 followed by what is the magnitude? 1. Okay. So plus 0 and plus 1. Now, if I want to represent minus 0, then what I'm going to use? 1 followed by 0. And let's say if I want to represent minus 1, then what I'm going to do? I'm going to use 1 followed by 1. So using 2 bits, I can represent 4 digits. So you can also see from the formula 0 to 0 to 2 power n is nothing but 2. 2 power 2 minus 1 minus 1. Okay. So I'm going to 0 to 2 power 2 minus 1, that is nothing but 2 minus 1. So 0 to 1. So using, so the positive numbers which we can, I can represent using this sign magnitude form of representation, if I have 2 bits, is nothing but 0 and 1. Okay. From this example also we can see it out. And let's say if I want to represent my negative numbers, then I'm going to substitute here in the formula minus 0 to 2 power n. 2 power 2 is nothing but 2 power 2 minus 1, that is nothing but 2 power 1. So 0 to minus 1. Okay. So this is how I can represent my numbers if I have n is equal to 2. Okay. Let's say if I have n is equal to 3. Let's say if I have n is equal to 3. 1 minute. Let's say if I have n is equal to 3, okay, then what are the numbers which I can represent? Okay, so what is that I can represent from 0 to 2 power 3 minus 1 minus 1, that is nothing but 0 to 2 power 3 minus 1 is nothing but 4 minus 1, that is nothing but 3. This is the positive numbers which I can represent. And coming to my negative numbers, that is nothing but minus 0 to minus 2 power 3 minus 1 minus 1 minus 2 power 3 minus 1 minus 1. Now, so that means nothing but minus 0 to minus 2 power 3, that is nothing but 2 power 2 4 minus 1 3. So 0 to minus 3. So these are the negative numbers which I can represent, and these are the positive numbers which I can represent. Now, so how it is going to look like? So triple zero, this is nothing but plus 0. And for representing my plus 1, what I'm going to write? For plus symbol, I'm going to have 0, and 1 is nothing but 0 1. And for plus 2, I'm going to use 0 for representing my positive sign and followed by 1 0. Okay. Now, coming to plus 3, how to represent my plus 3? That is nothing but 0 for representing my positive sign and followed by 1 1. So this is how I can represent my positive numbers up to plus 3. Now for negative numbers, that is nothing but minus 0. How to represent this minus 0? Minus symbol, nothing but 1 followed by magnitude, that is nothing but 0 0. And minus 1, that is nothing but 1 followed by 0 1. And minus 2 is nothing but 1 followed by 1 0. And minus 3 is nothing but 1 followed by 1 1. So this is how I can represent my positive numbers and negative numbers in the sign magnitude form of representation if n is equal to 3. Now, so these are the examples which we have now. Coming to next type of representation is nothing but my ones complement form of representation. Now, if I want to represent any numbers in ones complement form of representation, let us try to understand how we are going to represent them. If I want to represent a positive number, then I'm going to represent as it is. That is, in the original form, I'm going to represent. But if I want to represent any negative number, then I'm going to perform a ones complement on the original number and I'm going to represent it. Now, what do you mean by this is, let's say if I have to represent plus 2, then I'm going to simply write it down 0, 1, 0. Okay, this is how I can represent plus 2. But if I want to represent minus 2, then I'm going to perform ones complement on this number. That is nothing but 1, 0, 1. And this is nothing but the ones complement form of representation on this number minus 2. Okay, let's say if I want to represent plus 5. Then how to represent this? 0, 1, 0, 1 is nothing but normal plus 5 in one's complement form of representation. But if I want to represent minus 5 in one's complement form of representation, then I'm going to perform one's complement on this original number, that is nothing but 1010. Okay, so this is how I'm going to perform, or this is how I'm going to represent my positive numbers and negative numbers in one's complement form of representation. Now, the range of numbers which we can represent using one's complement form of representation is 0 to 2 power n minus 1 minus 1. And for the negative numbers, we are going to use minus 0 to minus 2 power n minus 1 minus 1. So for example, if our n is equal to 2, then that means we can represent from 0 to 2 power 2 minus 1 minus 1. That is nothing but 0 to 1. Okay, and this is nothing but my positive numbers range, and for negative numbers I can represent from minus 0 to minus 2 power 2 minus 1 minus 1, that is nothing but 0 to minus 1. Okay, so this is nothing but my negative numbers range. Let us see with one example. So if I want to represent plus 0, okay, I have only 2 bits, so I'm going to write down 0 0. Let's say if I want to represent plus 1, then how to represent? Then it is nothing but 0 1. Okay, I have only 2 bits. Let's say if I want to represent minus 1, then how to represent this minus 1? Then, okay, if I want to represent minus 0, how to represent this minus 0? Just perform one's complement on this number, that is nothing but 1 1. And if I want to represent minus 1, then perform one's complement on this number, that is nothing but 1 0. Okay, so if you have only n is equal to 2 bits, if you have only 2 bits, then these are the range of numbers you can represent using the one's complement form of representation. Now, coming to, so what is the advantage? Advantage of over sign magnitude form of representation is you can simply represent the negative numbers just by flipping the bits, and it is a simpler representation compared to sign magnitude because we don't need any other extra bit for we are not allocating any extra bit for representing our sign. Okay, but one of the disadvantage is again we have two representations for plus 0 and minus 0. Okay, so that is a disadvantage we are having in our one's complement form of representation also. Now, next coming to two's complement form of representation. Now, in the two's complement form of representation, a number is basically created by adding one to one's complement. So again, the same thing. If I want to represent any positive number, then I'm going to represent in its original format. And let's say if I want to represent any negative number, then what I'm going to do is I'm going to perform the 2's complement on the original number for representing any negative number. For example, if I want to represent minus, or if I want to represent plus 2, then I can simply represent it as 0 1 0. Okay, but if I want to represent minus 2, then I'm going to perform 2's complement on this number. Now, how to perform 2's complement on this number? The trick already we have seen in our previous sessions. Now, how to perform this? If you found a 0, just write it down as it is, and if you found a 1, you can write it down as it is, but from then you need to perform the complement. This is nothing but 1. So this is nothing but my 2's complement representation of a negative number and a positive number. Okay, so for a n-bit number, the range of representations for a positive number is 0 to 2 power n minus 1 minus 1. And for the negative range, it is minus 2 power n minus 1 to minus 1. Okay, so these are, we don't have minus 1 here. Okay, okay, we do have this minus 1, sorry. Okay, so these are the range of numbers which we can represent using the 2's complement form of representation. Okay, now we don't have two representations for plus 0 and minus 0. So for plus 0, let's say 0 0, form of representation is nothing but 0 0 only. So we don't have something like two representations for plus 0 and minus 0. So this is about the different type of representations in um, format in our hardware representations, because we use in our computers for storing our negative numbers, we use our two's complement format. Why? Because first of all, the main reason is unique representation of zeros, where your sign magnitude and one's complement form has different representations for zero, but whereas your two's complement is only going to have a single representation, and we have efficient range utilization. So these are nothing but my one of the advantages of using two's complement representation over one's complement and sign magnitude format. Yeah. So that's all about this particular session. In our next session, we are going to discuss binary addition using one's complement and two's complement form of representations. Thank you.